Today we are tackling LeetCode problem 44, which is called Wildcard Matching. It's one of the challenging higher-level problems that utilizes dynamic programming. As this is the final video in our DP series, make sure you watched our previous tutorials if you need a refresher on DP fundamentals. Now let's dive into the problem description. So it's LeetCode problem 44 and it's called Wildcard Matching. So given an input string S and a pattern P, implement wildcard pattern matching with support for the two special characters. One is the question mark and the other one is the star character, where the question mark matches any single character and the star matches any sequence of characters including the empty sequence. So with the question mark, it matches any single character, but an empty character, an empty string is not matched by this question mark. On the other hand, star matches any sequence, and that includes an empty string. The matching should cover the entire input string, not partial. So it's kind of a regular expression problem. So here we have three examples, so let's quickly go through them. If S is a string AA and P is A, the output should be false. Why? Because A does not match the entire string AA. So it matches the first half of the string or the second half of the string because they're equal. The characters are equal. However, it does not match the whole string S, that's why the output should be false. In the example 2, when S is AA and P is a star, in that case the output should be true. Why true? Because the special character star matches any sequence, and AA is a sequence, so therefore the output should be true. And in the third example, if S is a string CB and P is a string and P or the pattern is question mark A, the output should be false. Why false? Because question mark matches any character, so it can match the character C here, but the second character in the pattern is A, which is not equal to B, and that's why the output should be false. So basically, in this case, P pattern matches any string that contains exactly two characters, where the first character can be any character, and the second followed by the character A. So AA, BA, CA, DA, those strings match the pattern question mark A. However, string CB does not. And here we have some constraints. So we can see that both S and P can have length not longer than 2000 characters. However, and empty strings are also valid. So the length of both strings S and P is an integer between 0 and 2000, including these boundary values. S contains only lowercase English letters, P contains only lowercase English letters, and it can contain question mark or star, kind of special characters. So constraints are pretty straightforward. So yeah, we can just make sure that S and P are not null at the beginning of our method, and yeah, then and any other string is valid. And yeah, we can also add a validation to make sure that S and P contains only English letters, lowercase English letters, plus the special characters in the pattern P. However, we are not gonna deal with that constraint. We can assume that that's always true, so we can just focus on the solution. Okay, So let's see how we can implement this solution. This is another dynamic programming or DP problem. So we will be using one of the two common approaches, which is, in this case, we will be using the bottom-up approach. So we will try to define smaller problems first and build up the solution in a table. So this problem is relatively similar to a medium difficulty LeetCode problem which was done in the previous video, which is called edit distance, if I'm not mistaken. And roughly the idea is the same. We just need to see how we can deal with the star character, which is kind of slightly which might be tricky to spot the idea. However, if you are familiar with the previous problem, this problem is gonna be quite similar. So as in the previous video, so we will solve this problem by creating an additional structure, a matrix or a table. We can call it DP, and DP of ij will be but in this case DP will be the table of Boolean values. So DP of ij can be either true or false for any ij, where I and j are integers between 0 and the length of the provided strings s and p. By the way, to solve this problem, as we'll implement the method which is called isMatch, which takes two strings as input, string s, which is the string, and string p, which is the pattern against which we will compare the string, and the output or the return value of the method will be a Boolean flag, true or false, depending on whether string s matches the pattern p or not. So we will create an additional table called DP, which is a Boolean matrix, where DP of ij will be true if first I letters or characters of the string s, let's call them define it as this, matches the pattern, first j letters of the pattern p. Otherwise it will be false. So DP of ij will be true if first I letters of the pattern of the string s matches the pattern first j letters of or characters of the pattern p. So the outcome apologies. So the outcome of this problem, so the final solution of the problem would be DP of m n, where m is the length of the string s and n is the length of the pattern p. So that would be the solution of the problem. So now you can see why we are taking the bottom-up approach. So basically we will build this table starting from DP of 0, 0, and then we will solve those smaller problems first, DP of ij, and to solve DP of ij we will be using the solutions of the previously calculated smaller problems for instance, dp of I minus 1 j minus 1 or dp of I j minus 1, etc. We'll see how we're gonna solve the problem. So that's how we are planning to take the bottom-up approach. And first, let's see what would be some of the edge cases, not edge cases, but initial values of this dp structure. So what would be dp of 0, 0? Well, it should be true. Why true? Because here we are comparing S is an empty string and P is also an empty string. And we can say that empty string matches the pattern, empty string pattern. So that's why this is true. Also, let's see what would be the values for dp of 0, j, for any j, where j goes from 1, 2, 3 until p dot length, until the length of the pattern p. So what should be dp of 0j? Well, in this case we are comparing an empty string with a pattern. Okay, so let's say that the pattern is star, or I'll write it here. Empty string we are comparing with a pattern, and pattern is, let's say it's star. So this is true. In this case it should be true, because star, or it can be like this, because star matches any sequence of characters, including an empty sequence. That's why it will be true. But what if pattern is something like this, ABC, and we are trying to calculate dp of 0, 1. In this case we are comparing an empty string with A, and this would be false. And the third case is, let's say that this is the pattern, and let's say that this is the pattern. So dp of 0, 1 is true in this case, but dp of 0, 2, what would be the case? It would be false, because an empty string doesn't match the pattern star B. And in general case, when calculating dp of 0j, it will be equal to, let's say it was star as well. In this case, dp of 0, 2 would be equal to dp of 0, 1 if the previous one was true. And because it's now star again, so star also matches an empty string, so it would be true in this case. So basically dp of 0j would be equal to if j p of j is star, then it would be equal to dp of 0 j minus 1. So whatever is the previous dp, otherwise false. Why false? Because if it's not a star, then definitely. So any character which is not a star, we know for sure does not match the empty string. But only if it's star, then it will match the empty string only if the previous pattern also matches the empty string. So that would be the formula. And finally, what would be dp of I 0? Well, it would be always false, where I goes from 1 to the length of the string s. So any string that does not match the pattern and the empty string pattern. So yeah, string ABC. So even A doesn't match an empty string, AB doesn't match the empty string, ABC doesn't match the empty string. So it would be always false. So now when we have the initial value for the dp, so dp of 0, 0 is true, dp of 0, 1, 0j is equal to dp of 0j minus 1 if p of j is a star, otherwise false, and dp of I0 is always false. So now when we have those initial values, how can we calculate the dp of ij? So first I characters of a string, let's take the string ABC and the pattern, let's say ABCDE, and the pattern for instance A star question mark CDE. And let's say that I is 3 and J is 3. So first ABC, if it matches A question mark C. So first we need to compare characters ith character with jth character of the pattern P. If they are equal, or the jth character of the pattern P is a question mark. So in this case, so let's say that I and J are 2, B and question mark. We are comparing these two. B is not equal to the question mark, but given that, so this part is false, but P of J is equal to the question mark. But in this case, this question mark matches this B, so the output of dp of ij in this case will be dp of I minus 1, j minus 1. So it will be equal to dp of the prefix or prefix string of first I minus 1 letters of the string S with first j minus 1 letters of the pattern P. If those two matches, in that case, or if those two prefixes match, in that case dp of I minus ij would also match, because ith and jth letters are either equal, or jth letter in the pattern P is the question mark. Otherwise, dp of ij is false. Why? Sorry, not, we have one more example. So if these two are equal, or the second or the pattern character is a question mark, then dp of ij is dp of I minus 1, j minus 1. So whatever is before. However, else if p of j is a star. So how can we solve this case? So if p of j is a star, then dp of ij would be either dp of ij minus 1 or dp of I minus 1 j. So if any of these two are true, dp of ij would be true as well. So let's see, and otherwise I'll come back to this because this one is probably the trickiest one to understand. Else dp of ij is false. So they are not equal. The second one, the pattern character is not question mark, the pattern character is not a star, then they are false. Simply they cannot match. So let's focus on this one. Let's say that we have these two strings A, B, C, D, E, okay, and we have something like this: A, C, and star. And let's say that j is 4 and I is 4. So we are here. So we are comparing D and star. So first of all, let's see the previously calculated dp value. So in this case, I is 4 and j is 4. So first of all, dp of I minus 1, j minus 1 is dp of 3, 3. Let's say that this is already calculated. ABC really matches A question mark C, because this question mark can replace this B and A and C, A and C. So this is true. dp of I minus 1 j. So that's ABC. Sorry, that's ABC and the whole pattern. It's also true, right? Imagine that this is calculated already. This has been already calculated. So why is this? So here we are comparing ABC and A question mark C star. So A, B, B question mark, C, C, and this can replace an empty string. And dp of I, j minus 1, so that would be A, B, C, D, and A question mark C. So this is false, right? A, B, C, but this D is not covered with the pattern, so it would be false. So these values have previously been calculated. So we are now calculating dp of ij. So dp of ij, we are comparing A, B, C, D and the whole pattern. So first of all, let's compare D and the jth character in the pattern, which is a star. So D and star. So it's the second condition here in this formula. And we said that it's equal to if dp of I j minus 1 or dp of I minus 1 j, if any of these two is true, then dp of ij would be true as well, otherwise false. Why is that the case? So if we take dp of ij minus 1, so we are comparing the whole prefix with the pattern which is smaller. And if this is true, it's not true in this case, but if this was true, given that the next character is star, and star can replace an empty string, it would all again be true, because whatever we have, a star, this will, let's say a matches a, but in this case a would match a star, and we can add as many stars as we want because they can replace an empty, they can match an empty string. That's why this would work. On the other hand, if we compare dp of I minus 1 j, and if this is true, let's say if I minus 1 j are abc and a question mark c, and then sorry, and this one, and then if this is true, which is true, we can add as many strings after here, and this would be true again, because this star can replace all of these characters. So as long as this is true, we can add as many more characters. It would all again be true. That's why this formula works. And yeah, if none of this is satisfied, then we would just say that dp of ij is simply false. And that's the whole idea of this solution. So let's quickly implement this, and yeah, that would be the solution for this problem. So as I said at the beginning, I'm not gonna be checking the input strings, at least not the second constraint or third constraint are satisfied, which tells about lowercase English letters. So we can assume that these strings are really lowercase English letters. However, I can add a simple check at the beginning if S is null or P is null. So as always, I'll be using Java programming language. We can throw an exception, throw a new illegal argument exception. Null values provided, something like that. But even this can be omitted if you simply assume that the constraints are satisfied. So now we can say something like this: int m is the length of the string s, and int m is the length of the string p, of the pattern p. And now we will need, sorry, int n. And now we will need a structure table which will have n plus 1 and n plus 1, which will be a matrix n plus 1 times n plus 1, which will be used to store these solutions for these sub-problems. So we can say boolean dp equal to new boolean of m plus 1 and n plus 1. So why plus 1? So we need m spaces to cover every character in strings s and p, but we need an extra space for the empty string, for empty strings use cases. So dp of 0, 0 will be empty string and versus empty string, but dp of 1, 1 would be first character of the first string versus first character of the second string. So we need that extra space. And let's start with the initial values for this dp matrix. So dp of 0, 0 is true. It's always true because empty string matches an empty string. Let's now calculate dp of 0i and 0j and i0. So let's start with comparing any character from S versus an empty string. So that would be I0 use case. So for int I equal to, it would be 1, while I is less than or equal than M, I plus plus, dp of I0 is false. I is false because any string, any character, basically any character or any string compared to an empty pattern will always be false, because simply empty pattern doesn't match a character or a string, and a non-empty string. On the other hand, if we are comparing an empty string with pattern, so with the first element of the pattern, with the first two elements, with the first three elements, and so on. So we will need to do something like for int j equal to 1, while j is less than or equal than n, j plus plus. So what did we say? If p dot character at j is equal to star, or else if it's not. So if it's not equal to star, then we can say that dp of 0j is false, because if it's not star, if it's not a star, then definitely it's false, because empty string doesn't match a non-star character. On the other hand, if it's a star, as we said previously, dp of 0j would be equal to dp of 0j minus 1. So if an empty string matches the prefix of a pattern, and the next element in the pattern is a star, then it would match that pattern too. Otherwise it would be false. So basically this is just to make sure to cover the star. Imagine that there are 5 or m stars or n stars in the pattern, then all of these stars would match an empty string. So as long as there is no unknown star element in the pattern, it will always be true. Otherwise, as soon as there is a single, let's say there is a question mark here, so it would be true, true, true for this. Here it would be false, and then it would be false after that, because at this point it breaks this chain. So yeah, that's how we initialize our dp matrix. And now it's time to implement, to gradually build up the solution by reusing the solutions from previously calculated solutions of these smaller problems. So we can implement for int I goes from 1 while I is less than or equal than m, I plus plus, and for int j goes from 1 while j is less than or equal to n, j plus plus. So here we have a couple of examples, a couple of cases. So let's start with a simpler use case. So if s.character at I is equal to p.character of j, so if they are equal, dp of ij would be equal to dp of I minus 1 j minus 1. So if they are equal, if their prefixes match, then they would match as well. Same applies if p.character at j is a question mark. So we can have here else if p.char at j is a question mark and use the same thing. However, we can simply add it here. So if this is true, or if p.character at j is a question mark, dp of ij would be dp of I minus 1 j minus 1. Else, if p.character at j is a star, we will cover that case. And else, it's not a star, it's not a question mark, and they are not equal, then in that case dp of ij is false. And at the end of the method, we will return dp of mn. That would be the final solution. So here, if it's a star, then we have two use cases. So we can say whether dp of I minus 1 j is true, or dp of I j minus 1 is true. If any of those two is true, dp of ij would be true as well, so because as we explained earlier here. So dp of ij would be either dp of I j minus 1 or dp of I minus 1 j. So if any of these is true, dp of ij would be true. So again, why this works? So if the jth character is a star, if the first I, so we are solving the ij problem. So if the first I characters of the string s matches the prefix, so first j minus 1 characters of the pattern p, then they would match the first j characters too, because star can cover an empty string, so we can add as many stars at the end, it would still be matched. On the other hand, so that's this case. On the other hand, if the prefix of I minus 1 matches the whole pattern, let's say ABC, then because the last element of the pattern is a star, it would match the following characters in the string S. So then it would match the first I characters too. So let's write this down again just to make sure that it's clear. So the first case, dp of I j minus 1. So we are comparing first I characters with first j characters of the pattern P, first I of the pattern S with first j characters of the pattern P. If we know that, let's say, ABC matches ABC, and then the jth character is a star, this would again be true because we can add as many stars at the end. This will this will always be true because star can replace an empty character. On the other hand, if AB matches if AB matches the whole pattern, then ABC would match. So we can add as many characters at the end of the first character. They would still be matching this because this star can replace any sequence of characters. That's why this works. I hope this makes sense. As I said, it's a hard problem, but if you're familiar with how this works, then it really becomes an easy, relatively straightforward problem to solve, and not that much. I wouldn't say it's easy, but it becomes more like a medium difficulty problem when you're familiar with this formula. So that would be the solution of this problem. Let's quickly try to test the solution against some input strings. So let's say that string s is, let's use the examples from here. So let's say AA and A, string pattern B is A, and so the solution is placed in the class called solution. So I'm gonna create an instance, solution s solution equal to new solution, and let's print the result. Result is s solution dot is match B. Oh, sorry, SP. We have a index array out of bounds, and I think I know where the issue is. Yeah, here. So when we are comparing first J or first I characters in the string, those would, because a string indexes start from 0. So here we have to compare. So to take the jth element of a string, it would be indexed with the value j minus 1. Okay, so the same applies here. Here we are comparing first I with first j elements of the strings. So first I element would end in I minus 1, and here j minus 1, and here it would be j minus 1, and here it would be j minus 1. It's a minor mistake, but yeah, it's good that we try. So yeah, the result is false in this case. Let's see another example. A and star. In this case, the result should be true. Yeah, it's true. Let's say the third example, CB and question mark A. CB and question mark A. In this case, it should be false. Yeah, it's false. And let's say CB, for instance, CB, and here, let's say question mark B, and then let's say DDD, and here we can add a star. So the output should be true in this case. Yeah, it's true. Why it's true? Because C matches the question mark, B matches this B, and then star matches any sequence. So including this, matches this for this. And finally, so the solution seems to be correct. Let's quickly go through the time complexity of the solution. So if m is the length of the string s, n is the length of the string p of the pattern. So here we have we created this matrix DP, which is n plus 1 n plus 1 times n plus 1 matrix. So here we iterate m times, here we iterate n times, so this is big O of n, this is big O of n, it takes that much time. These are simple checks, so this single iteration of this for loop takes constant amount of time. And here we have a nested loop, so which takes m iterations, the outer loop, the inner loop takes n iterations, so we have m times n, and here all of these checks take constant amount of time, so a single iteration of this inner loop takes constant amount of time. So for the whole solution, this nested for loop takes the most of the time and basically drives the whole time complexity of the solution, and which would be m times n, big O of m times n. So time complexity big O of m times n, where m is the length of the string S and n is the length of the pattern P. Speaking of the space complexity, so to calculate these sub-problems, the solutions of the sub-problems, we created an additional table, dp, which also takes an extra m times n spaces, or n plus 1 times n plus 1 spaces, and because of that the space complexity is big O of n plus 1 times n plus 1, or we can say that it's big O of m times n as well. So this solution the time complexity, I don't think it can be improved. However, the space complexity can be improved to be big O of m or big O of n, whatever is smaller. And I'm not gonna do it here because if you see here, anytime we are calculating dp of ij, we are just considering the values from the previous row and the previous column. So we can definitely save some space and use an array instead of a matrix here. But yeah, I'm not going to do it here. I've already done something similar in one of the previous videos in this DP series. So yeah, I'll leave it to you to improve the space complexity of the solution. That would be all for this video. I hope that you liked it. And as I said, this is the final video in the DP series. From the next video, we will start a new topic, which is probably going to be a greedy approach. So I see you then. Bye-bye.